Good afternoon, everyone, and thanks for joining GovLoop's State and Local Government Innovators Virtual Summit. I'm Francesca Alatrush, staff writer here at GovLoop. I'm delighted to be your moderator for this last session of the day and hope you've been enjoying today's virtual summit. As we head into this last session, let's get ready to talk about making your day more efficient. Government reports often languish in perpetuity, stalling valuable information from making it into the hands of decision makers. But what if these critical reports could be generated, processed, and filed faster? What if instead of months or even years, agency reports could be processed in days or even minutes? The great news for many state and local agencies is they can be. The key is for agencies to maximize the power of data analytics and the cloud. But how do you actually implement these solutions? Luckily, we have some awesome experts here today to help us explore how automation, machine learning, and even artificial intelligence are improving agencies' ability to improve response times on critical reports. And before I introduce you to these awesome experts, let's go over a few housekeeping items. First, I highly encourage you to engage with one another and share your ideas and insights via Twitter using the hashtag GLTrain. We will be taking questions toward the end of this session. Just look for the Q&A box on your screen to submit your questions. Any questions that are unresolved will be answered over email. We hope you don't have any technical difficulties today, but if you do, look for the help button on your console, and Megan Dotson from the GovLoop team will help you troubleshoot any issues. Speaking of the console, we have several resources available for you to download throughout the virtual summit. Check to the right of your slide window for a few of these resources and be sure to download them for further reading. If you want additional resources, check out the Microsoft booth in the Innovation Center. In fact, the more resources you download, locations you visit, trainings you attend, and people you chat with, the more likely you are to climb that leaderboard. Those who end up in the top 50 will obtain the ultimate swag bundle. Finally, we are giving out 1 CPE credit for your participation in today's training. Be sure to take all 3 polls, watch the entire session, and fill out the post-event evaluation to obtain your CPE credit. And speaking of polls, let's get to your first one. What are your agency's biggest challenges in terms of improving response times on critical reports? Are they availability of funds, lack of collaboration between departments, or lack of the right technologies and solutions? And while you answer that, just a reminder, the CPE evaluation can be found in the resource module on your screen or in the Resource Center located in the virtual environment. For those who are eligible, the CPE certificate will be emailed to you on Friday, September 29th. All right, so let's check out those results and see what you guys answered. So it looks like the majority of you kind of fall in lack of collaboration between departments at 42%, followed by lack of the right technologies and solutions at 34%. So hopefully our experts today will be sure to help you out with some of these challenges you're having and help you get those critical reports out faster. So let me turn it over to introducing our speakers. Today we're going to hear from David Gollob. David has over 30 years of experience working in database and analytics systems. His work at Microsoft includes both his delivery as a principal consultant as well as managing consultant, where he founded the Microsoft Telecom practice. In his role, Dave travels the Western states visiting state and local government customers, evangelizing and assisting with data, big and small, architecture planning, advanced analytics, and solutions design. Dave enjoys his time with his family as well as mountain biking, skiing, hiking, and fishing in Colorado. And joining David for questions and answers via your training console is Bin Tao. Bin is a database cloud solution architect for Microsoft. He is a certified database master and enjoys helping Microsoft's government customers apply database and advanced analytics to solve real-world problems and create digital transformational outcomes. So, Dave and Bin, thank you so much for being here today. With that, I'm going to go ahead and hand the reins over to you, Dave.
Great, thank you, Francesca. It's fantastic to be here and speaking on behalf of Ben and myself. We're really excited to talk about an interesting solution that we hope will get your creative juices flowing. So let's begin. This is a picture of an ash tree in my front yard. And it's a beautiful tree, and I want this tree to live another 50 years. And I think I might have given it away. This is an emerald ash beetle. And I don't know if any of you know what this beetle does, but this beetle loves to eat ash trees. And I don't know if everybody knew this, but 3.4 million acres of lodgepole pine were killed in Colorado by the pine boring beetle. And this solution is about saving trees in our public areas, saving the ash, the oak, the pine, in parks and in public easements. So what's a traditional approach that Parks and Rec or city managers might take to solve this problem? Well, they'll commandeer the experts, they'll identify the beetles, they'll record them, count them, locate them, analyze them, and then prioritize eradication plans for these boring beetles. Easier said than done. This approach is costly. Even if you can find available experts, they could be expensive. There's very little collaboration. There could be false positives and false negatives, and there's really no collaboration at all. The recording could be of these beetles, could be skunkworks, photos, notes, and the analysis might be done in Excel or on paper. And in the end, the time to action, it may be too late for the ash tree in a certain park or in a public easement. So, introducing the boring beetle eradication solution, let's consider or think about a solution that would enlist our citizens and our volunteers in a socially interesting and civic-minded way by offering an iPhone app. And we're going to take advantage of cognitive services to identify species of beetle. We'll store those results into an Azure SQL database and a Cosmos DB. We'll talk about that a bit later. And there will be predictions for those images of beetles that are stored, indicating the likelihood that they're one of these pests that kill trees. And then we're going to visualize and author in Power BI for self-service reporting so we can make some proactive decisions around where to target our eradication plans. So let's talk a little bit about cognitive services. Cognitive services, there's roughly 20 different services across vision and speech, etc. Oh, this particular solution, this boring beetle solution, will use a service called the Custom Vision service. However, for just very brief education, we're going to look at the Face API cognitive service because it's very much in the news today. And if you go to our website, you can actually upload an image of a face, and we will then produce a JSON document that describes what we learned from that face, including sentiment, gender, was the face, were there glasses on the face, how about lipstick, emotion, what is the likelihood that the face was angry or disgusted or fearful. So this is an example of what the cognitive services do. They all produce these JSON responses based on the particular model and how it's been trained. So all of the cognitive services solutions, they are REST APIs, and a developer loves that because they're fast and easy to work with. And the theme throughout this solution, this deck, is about easy and efficient. And that doesn't just apply to those that author reports and consume reports, but it applies to those that build the plumbing that make the AI consumable and operational to those that look at the Power BI reports. And I'm going to walk you through all of the aspects of a solution that use this boring beetle eradication as our use case. So introducing the boring beetle beatdown app. You have to have an interesting name for your app, right? This unique strategy makes the hypothetical solution work. This is where we enlist the help of our citizens and volunteers to snap pictures of beetles and insects in and around trees during their walks, runs throughout the park, public easements, and things of that nature. And you're looking now at the boring beetle eradication, the full solution. Now, the iPhone app, admittedly, is not yet developed, but I will speak briefly to some development accelerators that Microsoft offers for iPhone apps. The subject of this talk, again, it includes the words fast. If you're interested in a solution like what I've prototyped here, because everything else is coded. I've coded everything else. If you were to look at something like this 10 years ago, it would have taken hundreds of thousands of dollars, months if not years to develop. Instead, this solution uses about 30 lines of C# code. There are no servers to stand up, no HTTP listeners, no SQL servers, no IIS, no Apache, no open source projects, no custom developed algorithms to deploy. So let's walk through this. And as you, and I hopped the slide there. As I walk through the solutions, I want you to focus on the red lines because that'll be the subject and topic that I'll be focusing on. And first, I'll take your attention to the iPhone app. And as I said, I didn't actually code this, but when I demo live, I simulate by uploading images to the Azure Blob Store, and we're going to get to that in just a second. But speaking about the app, there is a great platform called Xamarin where developers easily can write cross-platform apps for the iPhones. So our app will allow the citizen or the volunteer to snap pictures of beetles and then upload them to an Azure Blob Store. And as you can see now, we're transitioning in our architecture data flow to where the image is uploaded to the blob storage. So we're going to need to create that blob storage in Azure. So let's do that. So we're going to search for the blob store in the Azure portal, and we'll find the storage account. And then we need to set up an Azure storage account, indicate what kind of storage. Is it hot or cold? Does it use standard or premium storage? Does our storage need any redundancy? So are there any requirements to make the storage redundant? And we now need to associate to the storage account a blob service and a blob object store. So we click on that. At this point, we need to create a container, and this container is where we're going to upload all of our Beetle image data. So we're going to associate a container with our blob service. And the container will be named Beetle Capture. So remember that. The name of the container is Beetle Capture, and we've said that it's a anonymous read-only. So we create the container. So now that we have a blob container in Azure, let's associate an Azure function with that blob store. An Azure function is an event-driven, serverless architecture. It's extremely easy for developers, there's that word easy again, to execute code when any number of supported events occur. Events such as HTTP requests or timer events. In our case, we're interested in the blob store write events. And this Azure function that we're going to create will execute whenever an image is uploaded to the Beetle Capture container we just set up. So we're going to go to the Azure portal again. We're going to search for function. We see function app. And we're going to deploy this Azure function application. And it's associated with one-to-many Azure functions. So we supply the app name. We define the hosting plan associated and associated pricing tiers, which allow us to choose plans appropriate for the execution characteristics of the associated Azure functions. For example, how many cores will we need? How about memory requirements? What about SSD storage? These will all be planned, and they go into the execution or what we expect of the execution of all the associated Azure functions. So now that we have our function app set up, let's create an Azure function. So clicking on Functions, we can use some common templates, or we can create a custom function. We'll choose the latter. And now we're going to choose the blob trigger C#. That's the template that we're going to use for our Azure function. And now for this function, we need to associate it. It's the Azure Blob Storage Trigger. We need to associate it with a path. And now you can see the path there, Beetle Capture. So anytime an image is loaded to Beetle Capture, it'll fire off this function. And then we provide some stubbed out code. If you were to upload an image now to Beetle Capture, this would run, and it will be then handed a streaming pointer to the image and the name of the file, and it would write into the log an entry that has the name of the file and then the number of bytes that are in that file. But we aren't going to do that. We're going to create an Azure function in Visual Studio 2017. And this is where the 30 lines of code come in. And you'll see that the container name here is different than in the deck, because this is actually my working prototype code. In the red box, you can see the pointer to the, it's spelled COG blob. That's the Cognitive Services blob. That's basically the picture of the Beetle. So the function is given a pointer to the image data and the name of the file. And then I created a function inside of this Azure function that just conveniently allows me to access the image stream. And from Visual Studio 2017, when I'm happy with my Azure function code, I can then publish it up to Azure. And now, fantastic, I get all the benefits of IntelliSense and debugging and all the great things that come with Visual Studio. So back to our solution. The Azure function is set up. And now what does that function need to do? It's doing three things, as this diagram depicts. The first thing, it's going to call the Cognitive Services Custom Vision Service. And then it's going to take the JSON response and insert it into the SQL database, and then it's going to insert it into the Azure Cosmos DB. And this is all building a platform for actionable insights in Power BI. And again, the plumbing, extremely easy for developers. So first, before we can call the cognitive service, we need to train a model. So we go to customvision.ai, and we're going to build and train our Boring Beetle project. We click on New Project. We give the project a name, and we establish a domain. Since we don't see a bug domain, we're going to choose General. You can see that there are domains like food, landmark, etc. And now we upload some images. So we're going to upload some emerald ash boring images. We're going to upload some pine borer images and some oak borer images. And this is where we come in. We need to tag each of the images. And this is what the algorithm will use to make itself smarter regarding boring beetle identification. You can see that for the images in this screenshot, we tag them as beetles, as boring beetles, and as emerald ash beetles. And you would do the same for all images that are uploaded. So now we need to train the model and say, based on the tags in the images, go out and try to establish some patterns and correlations. And it executes. And it's a pretty, for those images, it's pretty effective. It performs well. Recall says that out of all tags, it should be classified correctly. What percent did it get right? And precision says, if a tag is predicted to be correct, what is the likelihood it got it right? So for those limited number of images, it does a pretty good job. And now we can do a quick test. So let's upload this image. And notice that that image, if you can see it, it looks really nothing like the images that we supplied. We know it's a beetle, but our model doesn't really know that's a beetle. It doesn't have spindly legs. It has a shiny body. So any guesses what our model will produce? Sure enough, our model says, I don't know what that is. I say there's a 0% chance it's a boring beetle or a pine beetle or oak beetle or any other kind of beetle. But if we load this image, I think we can probably guess what comes back. The model indicates 100% chance this is a beetle, and the model believes a 100% chance it's a boring beetle and a 100% chance it's an emerald ash beetle. So that basically would mean that we would maybe need to continue to load other images and tag them as appropriate, making our model more thorough and smarter. But anyway, also in the portal, for a given model, we can access the REST API URL. So this data that I'm pointing at here, this is what we're going to need in our REST call within our Azure function. That has everything. It has the prediction key, the project key, the content type. That's the stuff that we're going to need. There we go. There's also this handy thing called an API test console where we can look at the different REST calls for a given cognitive service. And that really comes in handy for testing and getting the actual JSON responses, and there's even code samples. So that brings us back to our Azure function. So part one, we're in our Azure function, and now it's time to call that REST API with the image data that was handed to the Azure function. So first we're going to need to allocate an HTTP client object. We're going to need to set our default request header to prediction key and give it the prediction key of our project. And we build out that REST URL string for the prediction call. Notice it has image at the end of it indicating I'm going to be supplying the image to the cognitive service. We need somewhere to put our JSON response. I don't expect everybody to be a coding expert, so I'm just kind of whipping through these things. We need a byte array that points to our image data that comes into the Azure function. And then there we go. Now we call the cognitive service with that URL, and we get a JSON response back. And that JSON response looks something like this. It's a document, and you can see right there, pine borer beetle for that particular image, 100% probability. Is it a borer? You get the idea. Down at the bottom, is it an emerald ash borer? Very, very unlikely, 0.0001. So we want to insert that job. You know, I'm going to take a little break now, and it is time for a middle of the presentation poll. And I'd like to ask everybody to click on how familiar are you with artificial intelligence and machine learning? And I'll give it about a minute. All right, that should be enough time. And it's nice to see there's a 37% that are fairly familiar, 60% not familiar at all. And hopefully this presentation kind of gives you a taste and a sense of how AI and artificial intelligence can be part of an operational solution. It's much more than just taking a picture of a face and saying, are they angry? I'm actually showing how we can solve a business problem. In our case, it's Parks and Rec and eradication of boring beetles, a very real problem. Great, everyone. So let's just continue with our solution. So we have our JSON response from the cognitive service. Now the Azure function needs to insert that JSON and associated metadata like time the image was taken, location, etc., into an Azure SQL database. So first we need to set up our Azure SQL database. So in our Azure portal, we search for SQL database. There it is. We need to give our database a name. It needs to be associated with a logical server so we can create a new server or associate it with an existing one. We then define the server admin and password. We indicate this database will not be part of an elastic pool, which is an interesting concept. Elastic pooling allows many SQL databases to share a common pool of compute resources and the databases can contract and expand as necessary. And then once the database is created, sorry, let me animate that through. Now that the database is created, we can also indicate should this database be geo-replicated. And so with just a click, we can replicate the database across the country, making it fault tolerant, and also it provides an alternate readable source to offload read workloads. We can also, having a little trouble with the slide navigation. I got it now. Okay. We can also just with a click enable auditing and threat detection. We can establish dynamic data masking, which allows us to create masking rules and masking functions that will limit what users can see when querying parts of our database schema. With a click, and I'm saying with a click again, easy stuff. We want to make sure that architects and solution providers and developers can get things on the ground quickly. With a click, we can set up encryption at rest for our data, our log, and our backup. We can also scale a SQL database instance as demands dictate. There are also premium models for SQL database instances that have high-performance premium solid-state disk, and these are typically for I/O-intensive workloads. From the Azure portal for the SQL database, we can also access the connection strings. So imagine you could migrate your on-premises database to SQL database, and for those applications that use that on-premises database, change the connection strings to point to your Azure SQL database, and you're off to the races. You now have an application that's using a database that's in the cloud. And for any of you out there that are database administrators, you're familiar with SQL Server Management Studio. And SQL Server Management Studio can connect to the endpoint for our Azure SQL database, and it looks like any other on-premises database. And here we can build our boring Beetle tables and store procedures and views, preparing it to receive the image data and the JSON data. And as a very quick detour, I just want to show you how easy it is to migrate an on-premises database to an Azure SQL database. So here we're looking at an on-premises database called PDX. And if I right-click that database, for those of you familiar with Management Studio, you have a number of tasks that can be associated with that database. We'll look down there, you can see Deploy Database to Microsoft Azure SQL Database. And this will work for many of our database workloads. They'll tend to be need to be slightly easier. The schemas will tend to be a little less complex. But for many of our databases, it could be just this easy. And then you're given the wizard to migrate that database to Azure SQL Database, and then it just lights up in the cloud. So back to our boring Beetle beatdown solution. So where were we? We're now back into our Azure function where we called the cognitive service. We have our JSON response representing the predictions for each of the tags related to that image that triggered this Azure function. But now we want to insert that JSON document plus some metadata like the date, time the image was taken. And I'm also going to insert into the Beetle table, I'm also going to insert a URL that points to the name of the file so that you could click on it and literally see the high fidelity Beetle image. So we need to build out our connection string. This is good old-fashioned ADO.NET in its simplest form. We create a connection. We build out our command string, and as you can see, I'm going to call a stored procedure. And I'm going to give it the JSON response, and as promised, there's the URL that points to the image. And then we're going to execute the command, and our job is done. We've now persisted the JSON and the metadata into our SQL database. And then the final data flow of our architecture, we're going to take that JSON and we're going to put it into Cosmos DB. And before we continue with provisioning Cosmos DB in the Azure portal, I want to explain what Cosmos DB is. It's a fully managed, globally distributed, horizontally scalable, I have to take a breath here, both scalable both in storage as well as throughput. And it's a multi-model database service. It's backed up by SLAs, and it's the next generation of Azure Document DB, if any of you are familiar with Document DB. Cosmos DB, it guarantees less than 10 milliseconds latency anywhere in the world, and it offers many predefined consistency models that you can choose from. Cosmos DB automatically indexes all the data, and it natively supports several NoSQL APIs. For example, we're going to be using the JSON-based document DB that has SQL query access. Also supported are MongoDB, another JSON database, Azure Table Storage, which is key value pair, and Gremlin, which is a graph model. So we search on Azure Cosmos DB in the Azure portal, and we need to establish a Cosmos DB account, give it a name, and again, we're going to choose the SQL on top of JSON document DB. And then for Cosmos DB, we need to define a collection. This is where we might group similar schema JSON documents, like the JSON that comes back from the custom vision prediction REST call to identify the Beetles. And we have to give our collection a name. We define its RTUs. One RTU is equal to 1 kilobyte document request, so 1,000 RTUs per second is pretty impressive. I don't know if we're going to have that much Beetle activity. You need a partition key to allow Cosmos to effectively partition and distribute your potentially enormous document collection and workload. And note that there's one-to-many collections associated with a Cosmos database, which we define at the bottom of this dialog. So there's the 1,000, there's our ID. That ID needs to be within your JSON document, and then there's the name of our Cosmos database. So a really cool utility that you can access to look at the Cosmos database collections is something called the Data Explorer. And with the Data Explorer, we can then look at the collection. So there's our collection name. And for a given collection, you can look at the documents within the collection. You can set the RTUs under scales and settings. We can define stored procedures, user-defined functions and triggers. And you can also author your select statements, because we're all familiar with select. And the result of your select statement will be a result list of JSON documents. Now, admittedly, this is some unfinished code in my Azure function. Normally, this is commented out when I do a live demo. I was just working on this on Friday. But essentially, we will allocate a new document client that connects to our Cosmos DB endpoint. And then I'm creating a memory stream for that JSON response for that cognitive services custom vision call. And then finally, I call the create document method. I give it the path to my collection, and I hand it the JSON document, and voila, it's now stored in Cosmos DB. And now we get to the really exciting stuff, and that's when we create visuals and analytics that give us great insight into these boring beetles in our parks and services and our public easement areas. So you see all that plumbing, which was very fast from a developer's perspective. For those of you that aren't developers, it might have looked complex, but trust me, if you're a developer, you're looking at that going, oh my gosh, that was profoundly easy. I set up a PAS SQL database. I set up a NoSQL database. I called into an algorithm, and all I needed is some URL and a few lines of C#. But now let's do some favors for those that author these reports. Let's just make it easy for them, and that's where they're going to access the Azure SQL database as their data store. So what we're going to do is we're going to download the Power BI desktop. That's a free utility that you can download. And we're going to launch the Power BI desktop, and we're going to go to Get Data. And then we're going to choose Azure SQL Database, and we're going to log in using the SQL Database endpoint and login, just like we did for Management Studio. And I'm just a quick diversion. Our SQL database, it uses views to provide a one-to-many result set. So one view is the parent table that has the image date time, the location, the URL for the image. And it has a relationship, a one-to-many relationship, with all the tags and the respective tags probabilities. Right? Because a JSON document, I just put that whole thing in one column in the table. I want to break that out into what we're accustomed to seeing, which is more of a relational layout of the data. So let's take a look. So now we get a couple views as promised, and we click on those. That data is loaded into Power BI Desktop. We can see that one-to-many relationship. And here are the results for the parent table. You can see lat longs and image date time. I don't right now show the URL. It's in there though. And then here's the child table, and you can see where I just put that red box. All the tags now each get their own row and the probability of that tag, and they relate up to that specific image. That's easy stuff for an analyst, a user, to author really interesting reports. There's no JSON, no need to deal with JSON. We've conditioned the data to make it really nice for end users to author great looking reports like these reports. So these are visuals that would allow a city manager, the city manager's office, to understand where certain born beetles have been sighted, where are the hot spots in the park areas, because we're using that map visual, as you can see. And then we can proactively plan for eradication efforts at the right place and at the right time. We publish our Power BI desktop file to the Power BI service in the cloud, and now city management can just use their web browser to go and look at those reports. They can click on the URL to get a detailed view of the actual Beetle image, and they can start making good decisions. And incidentally, I can also embed that Power BI report right inside of my public-facing Parks and Rec website. And this allows citizens to participate, showing the latest loaded images. It creates a real sense of civic pride toward the goal of saving the parks and the easements and the trees. So that's our full operationalized cognitive services architecture, soup to nuts. You could also extend and expand that architecture to include SQL Data Warehouse, analysis services as a service, a platform as a service in the cloud, reporting services. So now we can maybe pull in and mash up forestry data, entomology data, seeding, staffing, safety, and easement data. And by using analysis services, we can create a very high-speed, business navigable model that could be leveraged by these visualization platforms like Power BI. Reporting services knows all about the spatial data type. Because we have lat longs in our data, reporting services, you could actually draw perimeters. You could say, for this perimeter in this certain area, did you find any boring beetles? So in any good solution, you really have the end caps. In our case, the input end cap is that app, or you could just upload images to the Azure Blob Store using something like the Azure Storage Explorer. So that's the input side. Those are the citizens volunteers. And then on the output side, these rich insights that were very easy to develop using the Power BI desktop, that allows us to then make our very effective decisions on where we will establish eradication plans and start to target any beetles that have been identified. And this is the final. What about managing and tuning the model? So as the citizens are uploading images, there might be somebody in the back office, some individuals that monitor those images, and they suddenly start to see some beetles showing up that they're being identified as beetles, but maybe not as boring beetles. So in the back office, the expert on beetles could go back to the Custom AI Vision project, and they could add those new images, tag them with new tags, retrain the model, and the model now becomes much smarter and much richer at identifying ever more beetles. And a really cool thing is this operational data flow that I have been walking us through. The reports will never change, nor will any of the code. It simply will pick up the new tags and their probabilities. And that brings me to nearly the conclusion of my particular part of this presentation. I think I have maybe one more minute. And a couple best practices for the custom vision service. When you submit images, you really want the subject to be clear. You want the subject to be, have different angles, different backgrounds, different textures. That way you don't get a false positive. Imagine if you always submitted the pine borer beetle with a dark blue background, then the algorithm might think that the dark blue background has something to do with pine boring beetles. So you really want to make sure that you train it with a good representation of different angles of the beetle in the wild. And when you want to play around with the images in the Custom Vision .ai portal, I recommend a staging project versus adding them to the production project where you would then iterate on these new images. Instead, create a staging project where you take any new images in and you look at them before you want them to become part of your production project. I also want everybody to know I started with there's 20 or so ever-growing cognitive services APIs available. That is in the commercial cloud. In the government cloud, we do have a handful of those cognitive services. And ever more are showing up in the government cloud. But I do want to point that out. I know the computer vision, not the custom vision, the computer vision API is in the government cloud. A cool thing about the computer vision API is you don't train it. It already knows. It knows what pavement is. It knows what water is. It knows what landmarks are, what sky is, what crowds look like. It knows what a weapon is. It knows what a face is. So you could do a lot of very interesting things with the computer vision API. And this data flow and this prototype code, none of that would change except the call into the REST URL. That would be different because it's computer vision versus custom vision. Otherwise, the pattern is almost identical. Now I'm wrapped up, and I'll turn it back to you, Francesca, to wrap us up with the final poll question, I think, right?
That's right, Dave. Thank you so much for that very detailed walkthrough. I certainly feel ready to develop and go launch my own boring beetle app. I certainly hope our audience feels the same. But thank you again so much for taking us through that. And it looks like we have a few good questions here for you from the audience. But before we dive into those, let's turn it over to our last poll of the day. Cloud and data analytics would be most helpful for your department or agency to deliver faster business insights, enhance employee productivity, keep valuable information safe, improve teamwork and collaboration, or all of the above. And while our audience goes ahead and answers that, Dave, let's start with a few rapid fires here from some of these great questions. First of all, one question is, this all seems like, excuse me, a very obvious solution here. So what do you think could be holding state and local governments back from taking this first step?
Yeah, that's a great question. I think number one, it's awareness. When I showed this solution to a large group of 100 state and local government customers in Sacramento, one of the agencies was Department of Fish and Wildlife, and they said, we hire an independent contractor to identify species of fish. Something like this would be incredibly valuable. And they were right. This is perfect for fish species identification. So I think it is a function of awareness first. And then once we have the awareness, then it would be a matter of getting the developers and the architects in a room and sketching out what the solution will look like. So I just think it's because we're at those early phases of these kinds of AI solutions.
Absolutely. That definitely makes a lot of sense. Thank you for that. Let's go ahead and take a look at the poll results. So it looks like majority of you answered in terms of what cloud and data analytics would be most helpful for. Majority, 65% of you said all of the above, which is great because what Dave has talked about here definitely can help you deliver on these action items. And with a few minutes remaining, let's ask one more question here from our audience. You mentioned too that awareness component, and do you have any best practices? Obviously from our recent poll question, a lot of people aren't even familiar with machine learning and artificial intelligence. How do you get started in training and educating the state and local workforce to use these tools?
Yeah, what's really impressive is the Azure resources on the web. And if you were to just go search Azure Cognitive Services, you will get the link to the Azure.Microsoft Cognitive Services offerings. And when you go to those offerings, you'll find documents, samples, pricing, videos. My recommendation is to let Bing be your guide, or Google, let Bing be your guide, and look at the way we've packaged up the resources, because we in our documentation we provide getting started tutorial, sample code, and it will get you there.
Great. Excellent. We have another member asking kind of about the security aspect to all of this. How do you ensure that you're keeping important data like citizen information safe?
Yeah, so very, very good question. If you're starting to take photos of citizens, maybe it's for when somebody walks into an agency or facility, we want to identify them by their face image. Maybe it's identifying homeless people and their latest medical and medicine prescriptions that they need to be taking and where they were last to get that. Yeah, so those face images are very important to have those as private images. So that's really where the government cloud is so critical, because we provide the security, the lockdown, and the encryption on all those images. And then the access to the apps, that would have to be authenticated for that specific individual to even use those apps. And you certainly wouldn't make any store anonymous read access in those cases. So you'd really lock down a whole security strategy across a solution. Again, mine was boring Beetle, so that you don't need a whole lot of that. But that would have to be an overlay design on top of your end-to-end solution.
Great. Definitely makes a lot of sense. Well, that actually does it for the time we have for questions. David, thank you so much for your presentation, and Ben via the console on the back end. Thank you all also so much also for your wonderful questions and comments. We're sorry we couldn't get to them all, but please be sure to head over to the Microsoft booth in the Innovation Center to get any more of your questions answered. A few quick reminders before we sign off. We will be emailing you a link to the entire virtual summit on Friday, so check your inboxes. You'll be able to access all of the online trainings again, as well as the 100+ resources. And don't forget that you can earn CPE credits from our online trainings today, including this one. Be sure to take the live polls and evaluation to get your credit. Remember to network with your fellow Govies and stop by the Innovation Center to visit our sponsor booth. By visiting all of the booths and participating in the virtual booth crawl, you can earn awesome GovLoop swag. And the leaderboard will show you if you rank in the top 50 most active summit participants. Our goal with these trainings is to provide you with the tools you need to help you do your job better. We really appreciate and value the work that you do every day, so thank you so much for taking the time out of your busy schedules to join us this afternoon, and thank you so much to Microsoft for making this online training possible. We hope you've enjoyed this summit today, and see you in the virtual environment.